So angle of repose. The weight of body W can be resolved into following components. W sin alpha parallel to the plane B. This component tends to slide the body down the plane. Second one, y cos alpha perpendicular to the plane B. This component is balanced by normal reaction or suffix n of the body A and the plane B. The body will only begin to move down the plane when W sin alpha is equal to F is equal to mu into Rn is equal to mu into W cos alpha. So Rn is equal to W cos alpha. Tan alpha is equal to mu is equal to tan phi, or alpha is equal to phi. So mu is equal to tan phi. So minimum force required to slide a body on a rough horizontal plane. Consider that a body A of weight W is resting on a horizontal plane B as shown. Let an effort B is applied at an angle theta to the horizontal such that the body A is just moves. The various forces acting on the body as shown, resolving the forces P into two components, that is P sin theta acting upwards and P cos theta acting horizontally. Now for the equilibrium of the body A, so R suffix n plus P sin theta is equal to W. Rn is equal to W minus P sin theta. So P cos theta is equal to F is equal to mu into Rn. Substituting the value of Rn for equation 1, we have P cos theta is equal to mu into W minus P sin theta is equal to tan pi. So omega minus P sin theta. So mu is equal to tan pi. So we can write as sin pi divided by cos phi into W minus P sin theta. P cos theta cos phi is equal to W sin phi minus P sin theta cos sin phi. P cos theta cos phi plus P sin theta sin phi is equal to W sin phi. P cos theta minus cos phi is equal to sin phi. So P is equal to W sin phi divided by cos theta minus phi. For P to be minimum, cos theta minus phi should be maximum. That is cos theta minus phi is equal to 1. So theta minus phi is equal to 0 degree. So theta is equal to pi. In other words, the effort P will be minimum if its inclination with the horizontal is equal to angle of friction. So P minimum is equal to W sin theta. Belt and rope drives. The belts or ropes are used to transmit power from one shaft to another by means of pulleys which rotate at the same speed or different speed. The amount of power transmitted depends upon the following factors: the velocity of the belt, the tension under which belt is placed on the pulleys, the arc of contact between the belt and the smaller pulley, the conditions under which belt is used. It may be noted that the shaft should be properly inlined to ensure uniform tension across the belt section. The pulley should not be too close together. In order to that, arc of contact on the smaller pulley may be as large as possible. The pulley should not be so far apart as to cause the belt to weigh heavily on the shaft, thus increasing the friction load on the bearing. A long belt tends to swing from side to side, causing the belt to run out of the pulleys, which in turn develops crooked spots in the belt. The tight side of the belt should be at the bottom so that whatever sag is present on the loose side will increase the arc of contact at pulleys. In order to obtain good results with flat belts, The maximum distance between the shafts should not be exceed 10 meters and the minimum should not be less than 3.5 times the diameter of larger pulley. Selection of belt drive. The speed of the driving and driven shafts, speed of reduction ratio, power to be transmitted, center distance between the shafts, positive drive requirements, shafts layout, space available, and service conditions. Then we can categorize into different kind of belt drives. First one, light drives. They are used to transmit small powers at belt speeds up to about 10 meter per second as in agricultural machineries and the small machine tools. Medium drives transmit medium power at belt speeds over 10 meter per second up to 22 meter per second in machine tools. Heavy drives. These are used to transmit large powers at belt speeds above 22 meter per second as in compressor and generators. Types of belts: flat belt, V belt, and circular belts. Flat belt. The flat belt is mostly used in factories and workshops where a moderate amount of power is to be transmitted from one pulley to another when the two pulleys are not more than 8 meters apart. V belt is mostly used in factories and workshops where a moderate amount of power is to be transmitted from one pulley to another when two pulleys are nearer to each other. Circular belt or rope. Circular belt or rope is mostly used in the factories and workshops where a great amount of power to be transmitted from one pulley to another when the two pulleys are more than 8 meters apart. Materials used for belts: leather belts. The most important material for the belt is leather. The best leather belts are made from 1.2 meters to 1.5 meters long strips cut from either side of the backbone of the top grade steer hides. The hair side of the leather is smoother and harder than flesh side, but the flesh side is stronger. The fibers on the hair side are perpendicular to the surface, while those on the flesh side are interwoven and parallel to the surface. Therefore, for reasons, the hair side of the belt should be in contact with the pulley surface. This gives a more intimate contact between the belt and the pulley and places the greatest tensile strength of the belt section on the outside, where the tension is maximum as the belt passes over the pulley. Cotton or fabric belts. Most of the fabric belts are made by folding canvas or cotton duck to 3 or more layers depending upon the thickness of desired and stitching together. These belts are woven also into the strip of the desired width and thickness. They are impregnated with some filler like linseed oil in order to make belts waterproof and prevent injury to the fibers. The cotton belts are cheaper and suitable in warm climates, in damp atmospheres, and in exposed positions. Since the cotton belts require little attention, therefore, these belts are mostly used in farm machinery belt conveyors.